Okay, this video is for CEP 650 week 15. We're talking about long QT syndrome, LQTS. Um, so let's start. Basically, we're talking about a long QT segment in someone's ECG, which is, of course, the mirror representation, so to speak, of um, prolonged electrical conductance in the heart. You are born with this disorder, um, and it has lethal potential in it from ventricular tachyarrhythmias, which may lead to fainting or syncope, cardiac arrest, and then sudden death. Um, the severity of the symptoms varies from one person to another, even within family members who carry the same rare genetic variant or mutation. Um, People can be asymptomatic for their whole lives, whereas others can develop the symptoms at an early age or a young age. This syndrome, because it's a syndrome, represents several different and conditions with similar symptoms. Um, if you remember, we differentiated the idea of disease versus syndrome. And even then, I can say that the literature sometimes uses them incorrectly. Um, so there's a few conditions that have already been grouped together. I think that if you look at the literature, still, we're kind of we should be over that point where they're not yet grouped together, but the history of this syndrome was that one condition was found and then another, and they weren't connected together, they weren't related, and then at some point they were all related and combined into one group officially, but it still is taking time for that terminology to get to each and every one of the healthcare providers. So you can see that we have 6 types of Romano-Ward syndrome. These are 2 researchers that found these 6 conditions. Then we have 1 type of Anderson syndrome, another researcher. Then we have 1 type of Timothy syndrome, another researcher, and 2 types of Jervell and Lange-Nielsen syndromes. Researchers tend to call the diseases slash syndromes slash conditions after their own name. Um, let's see. So these conditions were found separately and later on associated as LQTS. Diagnosis, obviously easiest through ECG. We can see different criteria for diagnosis from a QT complex of 470 milliseconds to 480 in females. Is considered generally suspicious of LQTC. We see that the 470 is for males, the 480 is for females, respectively, in the absence of medications, of course, which prolong the QT complex. So we want to make sure that it's not originating from any kind of medication that someone is on for a different disease or condition. Not all of them have a prolonged QT complex at first on ECG, so it might develop later on. You can see that in 30 to 50% of the cases, the QTC overlaps with the normal range, and over 10%, it's less than 450. 440. Sorry, 440. Um, in that range of the normal range, of course, diagnosis is inconclusive, but you can suspect, and then it would be great to have someone be exercise test, hoping that it will appear through or be exercise induced. Of course, we can use the epinephrine QT stress test, and we can always use genetic testing because we're assuming it's inherited. Symptoms go from pre-syncope, meaning almost fainting, to full syncope, um, palpitations, ventricular arrhythmias, especially tachycardia, torsade de pointes, ventricle fibrillation, cardiac arrest, and we can talk about cerebral anoxia, um, which might be misdiagnosed as seizures. Of course, just to remind you too that anoxia is the complete absence of oxygen, in this case to the brain. So we're talking about brain damage. The genetic information, it's an autosomal dominant disorder. Once again, not linked to the sex chromosomes. It's not X linked, it's not Y linked. It's dominant, so one copy, one defective copy from one of the parents is enough to have the disorder or the syndrome. Um, it's equally divided between sexes, so you have a 50-50 chance between sexes to have the disease or the syndrome. Um, we can talk about um, 15 genes that have been found that are connected to ion channels within the cardiomyocyte, right? So this is a heart muscle cell, basically, in the membranes. And of course, when we're talking about ion channels, just remember that there are multiple types of channels, so it makes sense that you might have mutations affecting different channels and hence different genes. Um, so you can see that um, we have an autosomal dominant inheritance pattern, but we have a few exceptions, whereas we can find two mutations within one gene. Uh, um, that's called a heterozygous compound. Then we have digenetic mutations, which are genetics mutations within different genes, and then homozygous, meaning the same mutation in both copies of a single gene. Um, so different, bottom line, different in variety of mechanisms that might cause the same mutation and the same outcome. Individuals with more than one mutation typically have more severe symptoms. I think that's a rule that we've seen before. It's known to be caused by mutations to the LQT genes. So there's more than one gene in this case, mainly the ones that encode for channels that deal with potassium, sodium, calcium channel kinetics, meaning the dynamics of movement within the channel. So this does not necessarily mean that the channel itself is affected in its structure, but its function is affected, usually time dependent. So we can see that several mutations affect the channel to be slower, and several mutations create a channel that is faster, meaning the amount of ions that pass per unit of time are either decreased or increased. So for instance, a shortened opening, meaning that you'll have less time for the channel to be open. In the case of potassium, These mutations can be found in LQT1, 2, 5, 6, and then JLN and JLN2, 1 and 2. Then we say delay. We can see that delayed closing. In this case, the channel is open for a prolonged time. In sodium channels is in QT as well. Not as well, sorry, in LQT3, which does not appear in the shortened opening time, and this overcharges the channel with positive ions. You can see that LQT1, 2, and 3 account for most of the cases, with an estimate prevalence of 45, 45, and 7. So that accumulates to 97% of the cases. Okay, we can see that more than 170 mutations, mostly missense, of the LQT1 gene have been reported. About 200 mutations for the QLT2 gene have been detected. So these are a lot of mutations, meaning that these genes are very unstable, and that you don't have many hotspots, because a hotspot is usually where mutations accumulate and are focused. So the gene in general is unstable, which is surprising in my opinion, because these are serious channels. These are important channels. Of course, we want the body to be perfect, but the ion channels of the heart are not something we would want to mess with. So maybe we're still in a stage of evolution where these genes have not become stable enough. Just remember that evolution can take millions of years. Then you see that 50 mutations have been found for the QLT3. So we're already at 400 mutations. That's a lot in 3 genes. So obviously they are seriously unstable, and that's why the majority of the cases are originating from these 3 genes. So you can immediately conclude that the other genes, although they can have mutations, obviously are more stable than these 3 genes. You can see that cardiac events are less frequent in congenital LQT3 cases than LQT1 and LQT2, but they're more likely to be lethal. Explanation: because they are at birth, the ability to cope with the symptoms and the outcomes of the mutations is lessened, but also their frequency is lessened. So it's a give and take kind of situation. Then you see 5 mutations for QLT4. That's already way less than the other genes. And the vast majority of mutations for all QLT genes combined are of missense nature. So just to remind you, missense means that you have usually a base pairing that is not what it's supposed to be. So you have one nucleotide being changed with another that leads to the codon losing its sense. So it's not replacing one actually existing amino acid with another. It's actually encoding to something that doesn't exist. So that's the missense. Okay. Sorry. I made a mistake. That would be nonsense. Nope. Sorry. I got confused. Missense meaning that you're coding for one amino acid instead of another. Not nonsense. Sorry. I apologize. Okay, so I'm not going to re-record the video because of my mistake, but just to be sure that I corrected myself once again, in a missense, you have a nucleotide changing another nucleotide that leads to another amino acid being produced instead of the one that you needed. Let's see. We don't know the exact prevalence. It makes sense because long QT complexes are not always suspected of being genetic, but it's estimated that it's 1 in 2,000 live births. And once again, it's estimated. I'm pretty sure that you feel comfortable knowing ECG, what the implications of a long QT complex means. We definitely have a change in the time that electricity is channeled through the heart and produced, and according to the changes in the ion channels within the heart, we know that this can be life-threatening at the more severe aspects of cardiac electrical conductance, especially those where the conductance is delayed. Current treatment, basically, they should avoid drugs that prolong the QT complex even more. We definitely want to manage, the intake of potassium and sodium and magnesium. In some cases, we see that we have a dilemma with psychoactive medications because they can prolong the QT complex, but on the other hand, we need to take care of treat the psychiatric conditions as well. So in some cases, those medications are still given, although we know that we're putting a person at risk. I believe that the differentiation between giving and not giving is exactly, how borderline will it bring the person to be. Current treatment, beta blockers are definitely the drugs of choice. You know that. With prolonged QT, in this case, the prolonged QT is based on a inherited condition, but the symptoms are the same. So you wouldn't differentiate greatly between the two if they have the same symptoms, right? Genetic counseling, obviously, if it's inherited, these people are frequently hospitalized to be monitored, especially if they have a cardiac event, which they do, and they tend to reoccur. So periodical, even if they're asymptomatic, periodical checkups are a very good idea for them. But then they don't have to be hospitalized. What else? So we want them examined on a regular basis. They can have an ICD, of course, implanted into them if needed. Some of them may need surgery, especially for the nerves that regulate heart function. Let's see. We can see that there is no prevention of a woman getting pregnant. However, of course, if you're going to get pregnant and you have long QT syndrome, you definitely want to be watched for complications, and then the baby immediately needs to be monitored after birth. Unfortunately, regarding future treatment, no breakthroughs, nothing that I can say, is going to somewhere beyond where we are. Right now, it is expected that medication become more efficient. We do know that is happening slowly, but that's not a groundbreaking treatment within itself. Exercising these people, they are advised for lifestyle changes. These include avoiding strenuous exercise in water sports, such as swimming and diving, um, because these people have the chance to pass out and then drown. So we want them definitely on land. Other sports should be avoided um, if they're going to trigger abnormal heart rhythms. So then we want them to avoid any kind of noises like buzzers, alarm clocks, or doorbells. This may trigger the symptoms through the nervous system. Um, in general, we want them to um, wear labels and bracelets that mention their condition uh, in case of an unexpected blackout, which is always a good idea if you know you black out. And then you can see that walking, moderate hiking, and biking and golf are suitable but need to be cleared by a cardiologist. And this is, of course, according to their tendency to faint and the severity of their symptoms. So that's all for week 15 in this course. As always, let me know if you have questions.